Dear students, I hope you are all well. Last week we discussed about the story of periodic table in which we understand about some laws given in historic times. One another periodic table was given by Mendeleev, which is, you can say, base for the new modern periodic table. So today we will discuss about Mendeleev's periodic table. So, the first meaningful and remarkable contribution in the field of classification of elements was made by a Russian chemist, Dmitry I. Mendeleev, in 1869. Mendeleev used a broader range of physical and chemical properties of elements as compared to those used by Lothair and studied the formula and properties of several compounds of an element. On the basis of these studies, he developed a law known as Mendeleev's periodic law. This law can be stated as follow. Okay. The physical and chemical properties of the elements are the periodic function of their atomic weights or atomic mass. So what Mendeleev conclude that the physical and chemical properties of any element in the periodic table are uh, periodic functions of their atomic weights. Okay, so following two inference can be drawn from his periodic table. First is the physical and chemical properties of the elements depend upon their atomic masses. Second, the dependence of physical and chemical properties of elements upon their atomic masses is periodic. This means that if the elements are arranged in the increasing order of their atomic masses, the elements with similar properties should recur after regular intervals. So, on the basis of his periodic law, Mendeleev arranged all the elements known at that times in the form of a table, which is known as Mendeleev's periodic table. In this table, the elements were arranged horizontally in 10 series in the order of their increasing atomic masses. These series were divided into 7 horizontal and 8 vertical columns. The horizontal columns were called periods while the vertical columns were named as groups, as they are also nowadays also vertical columns are known as groups and horizontal columns are known as periods. Mendeleev tried to place the elements having similar properties in the same group. At several places, he ignored the order of atomic masses in order to group together the elements having similar properties. Mendeleev's original periodic table contained about 65 elements known at that time. He left several gaps in the table for the unknown elements and predicted their properties on the basis of the properties of other elements present in the same group. So you can think that how wisely Mendeleev made his periodic table. Later on, when these elements were discovered, their properties were found almost similar to those predicted by Mendeleev. With the discovery of more and more elements, it was realized that Mendeleev's periodic table should be revised and the new elements should be included in it at appropriate places. Hence, in order to accommodate the new elements and to remove some of the defects of the original table, the original table proposed by Mendeleev was modified. The modified form of Mendeleev periodic table is given in table 5.1. In this table, the number written in bold above the symbols of elements represent the atomic numbers, while those written below the symbol of elements refer to atomic masses. Okay, so you can see uh, here something. Uh, if you consider think that bold above the symbol elements represent the atomic numbers, but nowadays atomic number will be present in lower side. Okay, so atomic number concept was given by Moseley later on. So atomic number concept which we read now in new modern periodic table, it was given by Moseley. So important feature of Mendeleev periodic table, if we see, first is series. All the non-elements have been arranged in 10 horizontal columns called series. In each series, the atomic masses increase in a regular fashion. And groups, there were 9 vertical columns in the periodic table. These are called groups. They are numbered as first, second, eighth, and zero. Except eighth and zero groups, all other groups are further subdivided, each into two subgroups designed and designated as A and B subgroups. Thus, we have subgroups like 1A, 1B, or second A, second B, you can say, etc. The eighth group consists of three sets of elements, each one containing three elements. The elements present in zero group are noble gases. These were not known at the time of Mendeleev's. The elements of a group show almost similar properties with a regular gradation. And third thing in his periodic table are periods. The 10 horizontal series have been arranged in 7 horizontal columns called periods, like that. These are numbered from 1 to 7. The first, second, and third periods consist of first, second, and third series respectively. The first period contains two elements, while the second and third periods contain 8 elements each. These are termed as short periods. The fourth, fifth, and sixth periods are long periods and contain 18, 18, and 32 elements respectively. These periods consist of two series each. Example, the fourth period consists of fourth and fifth series. The seventh period is incomplete. At the present, it contains about 23 elements belonging to the 10th series. Okay, if we talk about present modern periodic table, the remaining elements are yet to be discovered. A few of them have been discovered recently, but their position in the periodic table are not finally decided. The elements in a period show gradual change in properties as one moves from left to right of the periodic table. Okay, if you move from here to here, there will be a gradual change in the properties of element. So, what was the contribution of Mendeleev's periodic table? That first is systematic study of chemistry. Okay, the chemistry was be systematized. So you can see that Mendeleev periodic table categorized the elements for the first time in a systemic way. Okay, this helped immensely in the study of chemistry of elements and their compounds and made the study much easier. If the properties of a group are known, one can easily guess the properties of all the elements and their compounds placed in that group. And the discovery of new elements. Mendeleev predicted the physical and chemical properties of some elements which were not known at that time and left gaps for them in his periodic table. This encouraged and helped chemists to discover these elements. For example, gallium and germanium were not known at the time of Mendeleev. Mendeleev named these elements as Eccle aluminium and Eccle silicon, Eka silicon. Okay, Eka aluminum and Eka silicon, because he believed that they would resemble with aluminum and silicon respectively in their properties. The discovery of these elements later on revealed that Mendeleev's predictions were remarkably correct. So you can think that aluminum was discovered by D. Bassey Baudron in 1875, who named it as gallium. Okay, and Eka silicon was discovered by Winkler in 1886. He and a new name, germanium, was given to it. And third is correction of atomic masses. Mendeleev's periodic table also helped in the correction determination of masses of several elements. For example, the atomic mass of beryllium was found to be 14.18 on the basis of its position in the periodic table. Mendeleev showed that beryllium was bivalent. The bivalent mass of beryllium was found to be 4.5. Therefore, the atomic mass of beryllium was corrected to 4.2 into 2, and it is equal to 9 atomic mass, equivalent mass into valency. So while you're reading, you have to see the modified form of Mendeleev periodic table, and you will be understand very easily. Okay, so you can see here that it's 10 number of series, and these are the 7 periods in the Mendeleev table. Okay, and these are the groups which were divided into 8th till 8th, first to 8th, and one zero group where noble gases are put here. You can see here. Okay, last. So these places are left by the Medley and Lanthanide and Actinide series. Nowadays it will be filled here. Okay, the name Rutherfordium and Curchativium have also been suggested for unequilibrium atomic mass, written in parentheses denote to the atomic mass number of longest lived isotopes. So you can see here. So this is the modified form of Mendeleev periodic table. So now one question is arise that why uh, new modern periodic table is needed. Okay, so there are some defects on the Mendeleev periodic table. First is the position of hydrogen. Hydrogen is an unique element of and resemble with the elements of first A group alkali metals as well as with the seventh A group halogens in its properties. Therefore, it should have been placed in both first A and seventh A group in Mendeleev periodic table. It has actually been placed in first A group in this periodic table. So this is one defect. Second is position of isotopes. In Mendeleev's periodic table, isotopes of element will be placed at different places due to their different atomic mass. This will be anomalous because isotopes possess similar chemical properties. Position of lanthanide and actinides. Position of lanthanides, photyl elements following uh, lanthanum and actinides. Okay, it's also anomalous in Mendeleev's periodic table. In this periodic table, all these elements are supposed to be placed together in third group, which is not in accordance to periodic law. Okay, variable valency of elements. So there are many valency also changes of elements, anomalous pair of elements, similar elements placed in different groups, and dissimilar elements placed in same groups. Eighth group, the group is full of anomalies. Except osmium, no other element in this group shows group valency. So no other element is octavalent. So these are some you can say defects in modern periodic in Mendeleev's periodic table. That's why the modern periodic law and long form of the periodic table, present form of periodic table, has been take place. Okay, so I hope you will be understand till here. If you have any confusion, you can ask. In next class, we will read about the modern periodic law or table. Thank you.